Dear students, welcome back to another video. Well, in today's class, we'll study the topic of chemistry, and you are looking at your screen, that is chemical equilibrium. It's a lengthy chapter in Matric's new chemistry book, which is just introduced by the STBB. So I have just divided this chapter into parts. So in today's class, we'll see one part of it, and you will study what is chemical equilibrium, what are the properties of chemical equilibrium, now reversible reaction, and then how the forward and reverse reactions are different. So let's start. Dear students, as you know that equilibrium refers to balance. And in case of chemical equilibrium, as the name is suggesting, that there is a balance in a chemical reaction. But what type of balance is this, and what are the conditions? We'll look further. So here, chemical equilibrium is a condition in the course of a reversible chemical reaction in which no net change in the amounts of reactants and products occurs. So you know that when a chemical reaction happens, then the reactants react together under certain conditions, and then they form a product. So chemical equilibrium is a sort of state in which there is no net change in the amounts of the reactants as well as the products, but there is a specific condition. This chemical equilibrium is attained only in the reversible chemical reaction. Now the question must be popping up in your mind, that what are reversible chemical reaction? So I would give you the example here. If you see the process of combustion in which the fuel is burnt in the presence of oxygen, then it gives off carbon dioxide gas. It is headed just in one direction, so it is unable to reverse. So burning, cooking, these are the irreversible reaction. However, in case of reversible chemical reaction, once the reactants react together and they form the product, then that product under certain conditions can give you the reactants back. We'll see further. So I just told you the chemical equilibrium. We'll see some properties. Now the properties of chemical equilibrium, there are two properties: forward and reverse reactions go on at equal rates and velocities. So the rate of reaction is basically, in this forward and reverse reaction, is same. The speed is same. The speed of combining of reactants to give the products, and then the decomposition of the products back into the reactants, they occur at the same pace, at the same speed. So this is one property of the chemical equilibrium. The other is the amount of the substances involved is unchangeable. Okay, so no net change in the amounts of substances involved. Okay, you must have observed in nature that when you do cooking, if combustion is happening, the digestion, that is burning of food inside the body, and the anaerobic respiration, we are giving certain products. Let's take the example of carbon dioxide gas. The carbon dioxide gas is being produced in these processes. What happens? This carbon dioxide gas is taken up by the plants, and then they utilize that carbon dioxide gas to make their food as well as the oxygen. The oxygen is used in all the processes that are happening in the surrounding. So this is the equilibrium in nature, and this also happens in your chemistry lab and even in nature. You can see here as the reversible reaction, a reversible chemical reaction is one in which the products, as soon as they are formed, they react to produce the original reactants. We just discussed it. So here's the example. If we react hydrogen gas with oxygen gas, so these two are reactants, and when they combine, so combination of them, it gives the product water. You see here, hydrogen and oxygen, these are two gases, and then they are producing a liquid, that is water. Here you can see the combination is happening, okay, under certain conditions. This reaction is basically a forward reaction. You can recover this hydrogen gas as well as oxygen gas from this water. So we can sum it up as hydrogen plus oxygen. This, when forward reaction happens, then water is formed, and when water is decomposing or it is splitting under certain conditions, so it gives you back the oxygen gas and hydrogen gas. In order to clarify the concept, I just added a picture here. So if you want to get hydrogen oxygen back, so what will we do? We will perform electrolysis. Here you can see the anode and the cathode. So when we do electrolysis of water, we can add electrolyte for this to happen, the electrolysis of water to happen. So we add electrolyte in this water, and when the electricity is passed, then hydrogen ion and the hydroxyl ion and further splitting of the hydroxyl ion into oxygen atoms takes place. And hydrogen atoms, they usually combine together and they form hydrogen gas, which is like hydrogen being positive, it is collected at the cathode during the electrolysis process, while oxygen being negative is collected at the anode. So this is how the reversible reaction is happening. And with hydrogen is combining with oxygen, and by its combination water is produced. And upon electrolysis, this water will give you back hydrogen gas and oxygen gas. I hope that this concept is clear. For further clarification, there is another example. So here hydrogen gas when reacts with iodine, and iodine gas is basically purple in color. You can see this is purple and hydrogen gas is colorless. So when they combine together in a closed flask, remember the flask is closed because both of these are gases and they can escape. So in order to make the reaction happen, we heat both of these gases, hydrogen gas and iodine gas together, and upon combination they give you hydrogen iodide gas, which you can see it is colorless. Hydrogen gas upon further heating can decompose, and by splitting you can get the vapors of iodine gas which are purple in color. So this is proving that iodine gas is recovering and the hydrogen gas is also produced. Since the system is closed, so you can get it. And this balance, this chemical equilibrium is happening in this closed system, okay? And you can see the amount is not changed, neither of the reactant and nor of the product. Now another example. In this example, just for the sake of simplicity, I just want to tell you that there are two conditions in which one system is open and only the forward reaction is happening, no reverse reaction is happening. However, in the other, the flask is closed, the system is closed. So here you can see when calcium oxide reacts with carbon dioxide gas, then it gives you calcium carbonate. Okay, so this is a kind of forward reaction. But in turn, when calcium carbonate is heated, okay, in an open system, then it will give you carbon dioxide gas and calcium oxide. Calcium oxide will be retained, however carbon dioxide gas being gas will escape. from the open system. So this is a kind of irreversible reaction, and it goes to completion. And this is one of the properties of the irreversible reaction, that they are complete reaction. However, reversible reaction are opposite to them. So if you close this and these flasks, then you heat calcium carbonate, then it will give you carbon dioxide gas and calcium oxide. So this way it is a sort of reversible reaction in which the equilibrium is established. It means the amount is restored. One thing you must remember, that when the reactants are reacting together and they are proceeding, they are moving forward, like they are doing the forward reaction to give you calcium carbonate, then the speed is fast. However, when you heat this calcium carbonate and you want to get carbon dioxide gas and calcium oxide back, so this will take more time as compared to the previous one, but a time is reached when the velocity of the reaction of the reverse reaction will be equal to the forward reaction. Okay, so this will maintain the equilibrium. So here you can see the difference between the forward reaction and the reverse reaction. So forward reaction is a reaction in which reactants react to form products. However, in reverse reaction, products react to produce reactants, and both of them are dependent on certain conditions. Forward reactions take place from left to right, while reverse reactions take place from right to left. Forward reaction, in them at the initial stages, the rate of forward reaction is very fast, and in case of reverse reaction, in the beginning the rate of reverse reaction is negligible, so it is a little slower. Forward reaction slows down gradually, and reverse reaction speeds up gradually. So that's it. I hope that you understood chemical equilibrium. I just tried to give you certain examples. Then we saw the properties of chemical equilibrium. After this, we studied the reversible reactions, and we saw certain examples. So I hope that you understood it. Have a very great time. Take care. I will see you in the next video.